Wasn't sure if I'd have time or not. So let's talk a little bit about de-icers and corrosion inhibitors. What I tell people when I talk about corrosion inhibitor de-icers is that it makes most sense to think about de-icers into 3 general categories. One category is just the basic chloride de-icers: salt, sodium chloride, mag chloride. Yes, you can measure some differences between their relative corrosiveness. But what I would tell you is that under field conditions, with all the variation we have, I don't know how significant they are. I generally consider all chloride de-icers to be relatively corrosive to steel. Then we've got the category of non-chloride de-icers. So now we're talking about the acetates, CMA, potassium acetate, urea, the types of de-icers that are commonly used in the aircraft world. These are all going to be relatively non-corrosive to steel. They're also very expensive. So there's a middle ground then of corrosion-inhibited de-icers in which we take a chloride and we add a chemical to inhibit its corrosiveness. Now, these will often test as being similar to these. You can get test results on corrosion-inhibited products that show that they're going to be similar in corrosiveness to a non-chloride. And I'd like to tell people, just be careful about that. Again, corrosion in the field is hugely variable. And a corrosion test is selecting one set of conditions to try and capture a fairly common type of exposure scenario, but not by any means capturing all possible scenarios. So I think it's pretty much certain that any corrosion-inhibited de-icer, regardless of what the test says, is not going to be as protective as a completely non-chloride de-icer is. So if you've got situations that are very, very corrosion sensitive, and you want the ultimate in protection, your best bet is always to go with a non-chloride de-icer. If you want to have some corrosion protection at a lower cost, corrosion-inhibited de-icers may provide a kind of a middle ground where you get some protection, but at a more manageable cost. Here's a graph that just shows you the relative corrosiveness of some common chemicals measured by the standard industry test, which is the PNS corrosion test. And again, the basic take-home lesson here is salt, calcium chloride, mag chloride, potassium chloride. Yeah, there's some differences in corrosion rate, but I don't think they're very significant under field conditions. The real take-home lesson is these chlorides are all much more corrosive than water, or something like potassium acetate, or CMA would be similar to this. That's what the PNS corrosion tester looks like. One final thing I think is worth pointing out. It is a common industry specification that liquids that are sold to make treated salt are very commonly required to pass the PNS corrosion test. And what I want to point out to you is, remember that it's the liquid itself that is passing the corrosion test, not the treated salt. When you blend that liquid, when you blend 8 or 10 gallons of that liquid with treated salt, the corrosiveness of your final treated salt product's not going to be the same as the corrosiveness of the liquid itself, which should make intuitive sense because you're diluting that corrosion inhibitor with lots and lots of extra salt. So this shows you an illustration of that. Here are 2 different commercial magnesium chloride with organic additive liquids. Note that the liquid itself both passes the PNS corrosion test. They both test as about 80% less corrosive than salt. But compare that now to the corrosiveness of salt treated with 8 gallons per ton of these liquids. Note that the corrosiveness of the salt blend the corrosion protection in the salt blend is a lot lower. Again, shouldn't be surprising, but just wanted to point it out. My belief is that the value of the corrosion inhibitor in liquids for treated salt is primarily going to be in protection of the equipment that's directly handling the salt. Because in that case, the liquid layer on the salt is going to be like a barrier between the steel that's coming into direct contact with it. But once it's all dissolved in the ice runoff and gets sprayed out into the environment, the effectiveness of that corrosion inhibitor is going to be decreased quite a bit. So that is everything I have. I've only got 1 minute. if there's any quick question, I can try and grab it. Otherwise, I will be over in the Cargill booth the rest of the day, and I would be more than happy to answer any questions that you have over there throughout the day. Thanks.